So here's where we've kind of gone through with our theory unit. We started with this assumption that computer science is basically step-by-step problem solving using the computer. That was why the first unit kind of got your brain in the right mindset. It talked about problem solving in a step-by-step way. It talked about way you can take a problem and break it down into smaller problems, i.e. top-down design. It talked about how when you explain something step-by-step, you can do that really in a very precise manner, almost like a very roadmap-like way, i.e. flowcharts. Okay? So that got your brain hopefully in the right mindset, because in computer science, that's what you have to do. You have to really explain things to the computer in a way that is really step-by-step. We usually call that coding or programming, right? So in coding, as you guys know, you're going to learn a language which translates your human thoughts into something the machine can do work with, okay? That's that process of problem solving, is explaining it that way. The language that we're going to program in is always a good choice between something that's good to learn on as well as something that has a professional edge to it. So we went a step further with that. We said, okay, if that's true, those fundamentals of coding would involve, and we did this through our first unit examples, the idea of remembering things or variables. That's going to be a whole unit we're going to study. The ability for the computer to remember things and solve problems. Something the computer has a lot of and is also useful for doing basic calculations. And you know that from math and science class. Then this idea of the computer making decisions or being able to be in control. Again, we're going to study that as a whole unit called conditional statements, but it's essentially that ability to ask questions, get results, and then act on those results. Make decisions, or in other words, be able to create a sort of fork in the road gate to decide to do one thing or another thing based on the way we write the code. Okay? So it's essentially in control. Building on that, we're going to do a whole unit in something called looping, which is that sort of thought process to the next level where it still makes decisions and is still in control, but it can do the same thing over and over again. As a machine, it's really good at this. Like most machines, it can do the same thing over and over again and still be in control. And then finally, we added in, well, since it's a computer program, we want to involve our users some way. We want to build an interface for the users to interact with. That depends on what we're writing, right? If it's some kind of game or if it's some kind of whatever, we want the users involved. They need to give us information and we need to give them information. So like an input-output sort of thing there. The output could be visual, it could be auditory, it could be whatever. The input could be whatever, mouse, keyboard, etc. Okay? Taking all that as a given now, okay, we now want to code and we need a way to do it. So in writing code, there's two big parts to making code happen. One is just a basic editor. Okay, we're not going to hand write code. So you know you're going to have to type the code. Okay? Now typing can be done in lots of different programs. Okay? The simplest would be something like a Windows Notepad program. Allows you to type in whatever you want. Okay? So that's the editor aspect. We can add words, we can delete words, we can do a basic spell check, we can do copy paste. Most editors can do that. I don't know any editor that can't do those basic things. It could go up as high as, say, a Microsoft Word or something like that. Can still do all that. Okay? But the editor would be nice if it could match the coding language. Like if I type computer code into Microsoft Word, a lot of it might show as a mistake because it doesn't know that I'm writing code. So the editor would be nice if it could match with our coding language so that it doesn't keep giving us errors like this is a mistake. Okay? As well, it'd be nice if the editor can keep our code organized. Being organized is a huge part of programming. So it should be nice if it could help with that. And as well, wouldn't it be nice if the editor could help us to learn the language? This is similar to programs like Microsoft Word. If you're doing an essay, I would suggest Word because it does all this. Plus it has, especially if you're writing, say, a French essay, you can set it to spell check in French. It can help keep your essay organized in paragraphs and stuff like that. It even has a built-in thesaurus and dictionary, so it can help you learn words to write that way. So we want that to apply to the coding language. So that takes programs like Microsoft Word out of the picture because they're not the best editor to use. Okay? But then it has to do one other thing beyond what, say, Microsoft Word does. It needs to do what's called a compile or a compiler. To compile, if you didn't know about computer science, just means to group things together, right? To compile it up. But essentially what that means is it's going to take your code and turn it into what the machine uses, okay? Because the machine doesn't really read code. Like the example I used in the first week, the idea of the light bulbs on the wall, it's just a machine. So the compiler is basically a translator to translate the code you write into something the computer understands, which is basically just light switches, right? It's a machine. So it's got to be able to read your code and turn it into something that the machine can execute, can run, okay? And it wants to do this efficiently, right? It doesn't want to, it wants it to be as good a code as possible, especially if you're coding something like a game that you really want it to perform well. You want that compile to be really efficient. But as well, you want it to help you. Since it's going to be making some sort of program, you kind of want to see what your program is going to look like even before you get done, a kind of a look ahead at what it's going to look like. Has any of you ever seen that acronym before, WYSIWYG? W-Y-S-I-W-Y-G. It stands for what you see is what you get, okay? That's an acronym that is handy in computers. Like in Microsoft Word, when you type your essay, that's what it should look like when it's printed. When you're working in PowerPoint and you're designing a slide, that's what the slide should look like when it shows, right? As opposed to doing it in something and you're not sort of seeing the result. So that's handy if it can do that, if you can kind of see what your program looks like. And then finally, it should actually make your program. Otherwise, what's the point? You're just writing code to just write it. You want to actually turn it into the actual program. So it's the combination of the editor and the compiler together. So there's a name for that. Okay? Well, there's several names for it. But the acronym that's generally used is IDE. Okay? Let's see if we can break down this acronym. Okay? Maybe we'll start with the D. It's the word that means to create and work within something. It starts with a D. Design is close, but not quite. It's D-E-V, and then it keeps going. Development, right, development. Now, development is often a word used in computer science. It means that idea to build something, okay? Now, let's go with the E. E is an easy one. It starts E-N. It's a word that describes, like, the place you're in. Environment, you got it, right? It's the environment. Environment, oh man, bad spelling. I'm not hired to do spelling with you guys. So what I'm saying is, we want an environment, that's the program, where we can do development. That makes sense. But what's the I? Close, close, you're in the right. It actually stands for integrated. What does the word integrated mean? What's that? Yeah, or to bring things together, right? You're integrating them, you're bringing them together. What we're bringing together is an editor and a compiler. We're bringing those worlds, the worlds are colliding, right? That's what IDE stands for. It's this integrated development environment. That's what I have written up here on this, that we're going to begin this IDE. So an IDE is just a name for these types of programs that allow you to write code in, okay? That's like you could call Microsoft Word one of a group of programs that's used for, what do they usually call them? What is a program like Microsoft Word called? If you had to categorize that type of program. A word processor, right? That's kind of a fancy word. Or a video game is a category of sort of programs. So the category of programs I'm talking about is called the IDEs, right? That's one way to describe them. Some people just call them like the coding world or whatever, but that's what they're called, right? They're integrated development environments. And so that is what we're going to learn today. We're going to learn about this programming environment. All right. So a computer program is just a set of instructions that makes the computer do something, right? So what we're going to use is this thing called the Visual C# compiler, or the Visual C# IDE. Let's be accurate in our description, okay? This is going to be the opening screen, although, yeah, I think this will be the one on your guys' screen. The good news about this is it is 100% free software. It's called the Express version because of that. There is a version that is not the Express version that they want you to pay for, Okay, so Microsoft offers the free version called the Express, and then there's one that you can pay for. For the purposes of this course,
Sorry for the interruption, Mr. Cardinal.
the Express version is more than anything you need. You don't need the professional version because it's expensive, right? It's sent to companies, right? So what it does is it gives you those tools, that worlds colliding, that integration of that. And what C# does, it's designed by Microsoft to really target the Microsoft Windows environment for making programs for Microsoft Windows. If you're a Mac user, this program is not going to fit your needs. It's not designed for working on the Mac. The actual C# is, but the actual Microsoft Visual C# is targeting the Windows environment. Okay? By the way, if you take my grade 11 course, that changes. Okay? But to do this, I have to introduce the concept of object-oriented programming. Now, this is a huge topic that I get into in way more detail in my grade 11 course. But I just want to touch on it because the concepts are fairly simple. If you look around the world, you see things that we could call objects, right? So for example, if I take this stool and put it up here on the table, it's an object. Here's some other objects, right? We do this naturally. Now, I could have called this also a chair, and you guys probably would have said, oh yeah, that's a chair. And I could have called this a chair as well, right? Now, in some ways, I'm classifying these both as chairs, but I could be more specific and say, this is a stool and this is a chair. Or I could just call them both chairs. Just like everyone in here, I could call you all students. Or maybe I could be more specific and I could say, these are the male students, these are the female students, these are the grade 10 students. I mean, there's lots of ways I could do this. We're essentially objectifying stuff or classifying stuff. Now, let's go a step deeper. With every object you get, there's usually two things that you can sort of use when describing it. One are its properties, right? Or its characteristics. So you could say height, weight, density, color. Those are all characteristics, right? Some kid could walk by the door right now and I could say, oh, that's a grade 10 kid and that's a boy and he's kind of stinks, right? I mean, whatever. I could come up with characteristics, right? But then the other thing you do with objects is you think, what could I do with them, right? What function can they serve? So I could sit on this. I could put like my coffee on it and make a little table. I could go all, was it WWE and like have a chair match with somebody in the room, right? There are lots of things I could do with it, okay? These four objects, you could think, okay, what are the properties of this object and what are its functions or what can I do with it? It's a simple concept. We do this all the time. Some of you might be entering the dating world and you might think, ooh, there's a person. Let's look at their properties and then, okay, I'm going to stop there. I think I'm going to get inappropriate. But you get the idea. Like, what could I do? Never mind. You get the idea, right? This is natural to us. We do this naturally. So it would be awesome if this entered the world of programming, which it does, obviously. So what objects in object-oriented programming is the objects are part of your program. And the way they're organized is an important sort of thing. And here you're going to see that sort of top-down, hierarchical sort of thinking come into play again. So for example, objects could be things like a button, or a character in a game, or a box to type text into. Those could all be objects. And this is huge when you're doing any kind of graphics in your programming. And what object-oriented programming did once it started was it made graphics programming more part of the mainstream. Okay, so let's imagine that we had a person as a fictitious object. Okay, so here's our person. They're the object. We could then categorize sub-objects of that person. So they have a head section, they have a body section. The head section has a nose and a mouth. The body has an arm, and the arm has a hand. Okay? This is a way we could organize stuff in terms of categorizing that person. So just in terms of some terminology, not stuff you need to know this year, but this could also be called the class, and classes below it are called the subclasses. Classes above it are called the superclasses. Okay? So for example, body is a subclass of person. Hand is a subclass of arm, which is a subclass of body. Okay? Person is the superclass of hand. Again, these are terms you don't need to know in my grade 11 course. They actually have more meaning. To go through this organization, we use what's called dot notation. Dot, not period. We use the term dot, okay? And when we go through them, we often use the word traverse. It just makes you sound smart. Traverse means to travel. So if I want to get to the hand, I've got to travel through the objects. So I would do something like this, theoretically. I'd say person dot, whoops, dot body dot arm dot hand. So using the dot in our code, we can access things that sort of travel through. Okay, just a simple concept, and you'll see how it applies in a minute. Now, objects have properties. So I look at that object and I'd say, okay, here's some of its properties. Size, color, shape. Those are properties of that object. Okay? I can sometimes read the properties, and I can also change them. So I can go, well, you know what, I'm going to change some of these properties. I'm going to say head.size, large. So here you see the dot, meaning the size property of the head is becoming large. Head.color is green, and it changes. Okay? So this is a simple version of code that's sort of kind of giving the computer a specific instruction. Head.shape, square, and it changes. Okay? And if I just said, hey, what is person.head.color, it should give me back the information I'm looking for. A very simple concept. Okay? And you're going to see how it applies to the code you write.
Computers can do that?
So this is the theory. A simple theory again. And we'll see how that relates to this. Okay. Now, in using object-oriented programming, some of the more technical aspects of what it gives you is something called RAD. RAD is not just because I went to high school in the 80s. RAD essentially means rapid application development. Rapid being the key word. Being able to do stuff fast. Making apps faster than just starting from scratch. Okay? This allows you to use objects that have already been built for you. You don't have to write the code. Somebody else did all the work. You just use the code. Okay? This is better than you have to do all of it yourself. Makes it for a shorter development cycle, easier to maintain, reusable stuff. This is a good thing for writing code. Now, we have to bring the user into this. Okay? So object-oriented programs are what are called event-driven. What an event-driven code means is your code sits waiting for a certain event to occur. That event might be clicking a button or moving a mouse. You determine what the event is, and then that will trigger something to happen. So when they click the button, I want something to occur. So you sort of wait for that event to occur. Okay. I think I just said that. Okay. So now we bring it home and we start looking at the Visual C# IDE for writing code. Okay? It's the application. That's the part we write the code in. The interface in terms of what we see when we write the code, and the code itself. Okay? That's the integration of all that. So there's the spot where we write the code. There's a spot where we can kind of get a peek ahead at what it's going to look like. What it's going to look like is essentially our user interface. Okay? And then there's the program itself that's making this happen, the C# environment. Okay? As I've said before. All right, so we're going to do this. We're going to start this up today just to get a feel for it. So that's what I want you guys to do right now. I want you to flip around to your computers. And I want you to click Start. That's the great question. And as you start typing in Visual C#, and the sharp is that symbol that is what you might call the hashtag or the pound sign. Okay, so there's going to be two of them on here. Okay? Okay, there's the 2008 and the 2010. Okay? Now, also be careful. If you just type Visual, there's another option. There's one called Visual Basic. That's not the one we want. So we don't want that Visual Basic. That's not what we want. We're going to be working in C#. We have two options, the 2008, the 2010. Well, of course we're going to use the newer one. So you're going to go to the 2010. The 2008 is still on these computers right now, but we're going to skip to the newer one. So you want to go to Visual C# 2010 and launch it. What I might suggest is to speed up your process. Oh, by the way, there's a couple other options. Be careful. There's also one called C++ 2010. You don't want that one either. What I might suggest is, you don't have to do this today, but I would suggest you make a shortcut somewhere. And I can help you with that if you don't know how to do that. Put a shortcut on your desktop, put a shortcut down on your start menu, on your taskbar, whatever. But that's what you want, because you're going to be doing this pretty much every day for the rest of the course now, is starting this Visual C# program. Okay. Looks like most of you have got it up and running. It welcomes you with a welcome screen, also known as the start page. Start page is just a place where you can see it just sort of gets you started, okay? So as you can see, you can quickly create your first application, etc. Once you've been working in this program for a while, it will also, I don't know if you can see here on mine, it keeps a track of recent projects you had open. That's a good thing, right? So if you were working on something, you can pick up where you left off. So it will keep track of older programs once you start, because you guys are starting for this for the first time, it's not there, okay? Okay, now, this IDE is different than, say, a program like a Word or Photoshop or something like that. When you work in Microsoft Word, you open and work on one thing, usually, and then you save one thing, and it's done. Photoshop, you open one thing and you save one thing. This isn't like that. This will be saving multiple files. Multiple. Most of them you're not ever going to touch. It manages them all for you. But just know that it's not saving one thing like a Word or a PowerPoint or a Photoshop. It's saving a whole ton of stuff. And that's what creates what's called a project. The project is a collection of all that stuff, and it makes a folder for you to save it in. Okay? So we'll start there tomorrow. We'll start right up there tomorrow. Start the C# program, or the C# IDE. Okay? It comes with a welcome screen, a start page. Okay? But obviously what we want to do is we want to start a project. And as I said to you guys last time, a project in C# is a little different. It's not one file, it's a collection of files. This is a jump from some of the software that some of you guys have used, like Word or even Photoshop, where when you save something, you're saving one thing. This is saving a big group of files. So it organizes it and keeps it organized for you by automatically making a folder for you and putting all the stuff in the folder, so you don't have to worry about it, okay? But just know that when you save a project in C#, it's going to make a folder full of stuff for you. Okay, that's handy. So let's do that. Let's set up a new project. There's a couple ways you can do this. Usually right on the start page is the option to create a new project, or if you have a project that you haven't been working on, you can open the project from that opening page as well. But that's not the only place you can do it. Okay? It's also available under the File menu. You'll see the words New Project, Open Project there as well. And for those of you who are like super into shortcuts, you'll notice that the little icon right there for a new project, that little picture that shows new project, also appears right on the toolbar right there. So that's three ways. I can go New Project, well, or I can click File, New Project, or I don't care how you do it, but let's do it. Let's make a new project. So when you click that, up pops up the first screen. And it says, okay, I'm C#. I want to make you a project. Here are the types of projects I can make. Now, some of you right now are going to get a little bit excited, because if you look down this list, you'll see Xbox 360 game, Xbox 360 game library, Windows game library. This is not a lie. This program can do these things for you, okay? You can actually use this program to write software and actually have it appear on an Xbox 360. It's not a simple 1-2 step process. There's several steps in place to do that, but it is entirely possible because, again, this is all made by Microsoft, so definitely can. But we're not going to be doing that in this course, okay? That's a little more advanced. It certainly lays the groundwork to go further into that. But what we're going to do is we're going to do the default. We're just going to make a Windows app, okay? Now, you'll also notice at the top it says Windows Forms app. Okay, the word forms is often confused. It's sort of a word that's used by, especially by Microsoft. But essentially a form is a window, okay? When you think of a program like Word, you say it's often running in a window. The word window was used by the company Microsoft for their operating system. But it was used before that, okay? Apple, for example, used to describe their things as in Windows, but then when Microsoft made it there, they stopped using that word, right? So a word that's kind of a little more generic is the word form, right? So this describes sort of a form. But anyways, I'm getting ahead of myself. We just want to then at this point give it a name, okay? So right now it's just called Windows Form Application 1. It has no other good name for it. It doesn't know what you're making, okay? So we're going to make our very first app, okay? Our very first program that's a real program. If you are a believer in luck at all, okay? If you are at all a believer in luck, the following is considered good luck. I don't care what you call it, because this is just an example. But if you believe in luck, it is considered good luck to call your first app Hello World, okay? So that's what I'm going to call it. There's a historical sort of significance to this, but I just like to say it's good luck. I don't want to go over the history with it today. I want to get diving into this. You'll notice the way I named it. Anyone notice something that we've kind of already learned a little bit about the way I wrote Hello World there? Camel casing, that's right, camel casing. Oh. So that's coming back. So it's good we kind of already had a little intro to that. Okay, that's good. So let's go okay, and then watch the magic happen, right? So now at this point, it's starting to set it up for you, okay? It's starting to get going. That's why it's taken a minute or so. The little spinning hourglass, if we were on the Mac, it would be that beach ball thing. And we're here now. All of a sudden, the world changed, and now we're here. Okay? Yours might not look exactly like mine. I can see right away yours looks a little different than mine. I think yours will look like this and like this, more accurately. But what you see right away is this. What you would probably describe as a little window, a little app window. What C# describes it as is a form. The words don't really matter, but that's what it is. That's already given to you. What actually went into building that is a lot of code that you don't have to worry about. This is already an app for you. And you can see it actually in remember what I called the WYSIWYG environment. What you see is what you get. This is what your app's going to look like. Now we can also use this IDE to test it, to see what it would actually play like before we do anything to it. And the way we do that is, again, there are several ways, but the most easy way to do this is up along the taskbar is a little button that looks like a green triangle. Now, what would you normally think a green triangle icon like that would mean? Yeah, play. Like if we were in a Windows like media player, that would be play. And that's exactly what it means. It means to play or to run your app. At this point, it does the compile that I was talking about last class. Down on the bottom, as you hit the play button, it'll start the process. This is a fairly simple app at this point, so it shouldn't take long, which it didn't. And now here it is. Here's my app. This is an actual app running. This is your app. Now you think, ooh, it doesn't do much. It does a lot, actually. Look, I can maximize it. I can minimize it. I can move it around. I can drag it around on the screen. I can resize it. Ooh, I can do all that. And finally, I can close it. Okay? Once I closed it, it shuts down. And we're back here in the WYSIWYG editor. What you see is what you get. Okay? Cool. Okay? Now, instantly your thoughts are, okay, I want more. Give me more. I want more and more and more. So now we have to rely on the IDE and the way it sets up the sort of the way we can work. Okay? This is similar to programs like, more so like, say, a Photoshop program. In Photoshop, the original design was, if you think like an actual artist, like say I'm not on a computer and I'm an artist, I'm sitting here, what would I do if I was going to paint a picture? I would pull out the supplies I'd need, right? So a can of paint here, maybe a can with some brushes, some pencils. I'd put all my tools kind of in a spot where I could use it, and in the middle would be the thing I'm working on. But as an artist, I might want to move some of those tools around. Photoshop and programs like that kind of try to mimic that environment. They say, okay, we kind of know the middle area is where you're going to be doing most of your work, so we'll set up tools kind of around it in places that you can kind of get at. So the first thing you're going to need, you're going to find along the side here, And sure enough, it's called the toolbox. So if you click on that thing, it will fly out. A little toolbox of tools will fly out for you. Now, the way it's set up by default is the second you click away from it, it flies back. So it's kind of trying to hide itself and stuff. Now, I actually find that a little annoying. You can love it if you'd like. But you can stop that by clicking the little pin icon right there, which essentially pins it in place. And then it's now stuck there. If you ever want it back in the fly in, fly out, unpin it. Now, my guess is, just a guess, I'm not a mind reader, but just a guess based on the hand that's up right now, one of you might have accidentally clicked the X, and now it's gone forever. Oh no, well, the way to pull it back is now you have to go up to the menu called Window, up here, okay? And you can, if you want, just reset the window layout. That's the easy way to do it. Or you can go up to the window called View, and then there's toolbars, other windows, etc. So this would be the one I would suggest. If you go up here to View, Other Windows, then you can check off Toolbox again to bring it back. Or you can just go to Window, Reset Windows to reset them all if you really mess things up. Now, it lets you do other things. Like if you want, you could actually drag the toolbox. If you want, I want it over here. You can put it over there. I want it up top. I want it on the bottom. You can do that if you want. But I think the most important thing is, if you want to pin it in place. Okay? This is the toolbox. So let's take 1 second to take a look at it. The toolbox organizes stuff into categories. Here you can see them. Most likely, the one that's in front of you is the one called Common Controls. You can open up or collapse these categories by clicking on the triangle. The triangle will open it or close it, essentially collapse it or expand it. What I do is I just want to see it all. So I just go to All Windows Forms at the top, and then I just see it all. To me, that's the way I want to roll. Okay? I want to see as much as possible, so I go to All Windows Forms. You don't have to. You're in charge here. You do what you want. So on here are all the stuff, the Windows, okay, sometimes called the Windows gadgets, which we often shorten to widgets. All the components that you can pull over and draw on your form. So now you're in kind of like a Photoshop type environment. So for example, one thing I can do with my form is I can stretch it. I can make it bigger or smaller by clicking on one of the 8 sizing handles that usually appear. Although in this one you're only going to get 3. Now let's say I want to put on there something like a button. Why not? So I go over here to the toolbox and I go, well, I wonder where that is. Oh, well, sure enough, if I look down a couple, there's something right there that says button. And it's even drawn a nice little picture beside it that looks like what a button should look like. So I click on the tool and nothing happens. Then when I move over to the form, ooh, look, my mouse changes, and if I click and drag, boom, a button appears. I can also, if I'm kind of lazy, just double click it over here, and the same thing happens. It just instantly pops it up over there. And then I can move them, I can resize them, I can reposition them. As you start moving them around, you'll notice C# tries to help you a little bit. It brings up some guidelines. Watch here as I move button 2 under button 1. See those little blue lines that'll start popping up or beside? This is to help you to position it. So if you kind of want them edged together, or you want this one to match the top, or as you're resizing, whoops, we'll get into that in a minute. So I'm resizing, I want them to be the same height, or if I go over here and I want them to be the same width, it helps you a little bit, okay? It helps you to kind of draw them out that way, okay? You can also use common tools like copy paste if you want. You can copy and paste a button and stuff. So as you can see, I'm guessing a lot of you want to experiment with this, right? Like, okay, that's one thing. I want to put tons of stuff on there. Totally going to do that. Just hang on. Got a few more things to do. So that's the first thing you do is you got your project set and you're going to start adding components from the toolbox. But we've missed one super important step that maybe none of you kind of realize, and I hope at least one of you did. What's the one thing we haven't done yet? It's the most important thing in the world. Yeah. If the power got pulled in this classroom right now, everything you did would be gone forever. This is a weird quirk in C#. When you start up a new project, it doesn't by default save it for you unless you ask to save it. So it kind of gives you kind of a working thing that you can kind of goof around with, but it doesn't actually save it until you ask to save it, which is why I'm going to recommend that that should be something you do right away, because you might forget about it. Now, luckily, if you try to shut C# down right now, it will ask you, hey, do you want to save this? Okay? But I think you should do that way before that happens. So as you can imagine, up here, these two icons are for saving. Do any of you guys actually know why those icons are? I think one year I'm going to ask a group and they're never going to know. That's right, they're floppy disks. But I bet you one year I'm going to ask a class and they're going to go, I have no idea. Why? Because they've never seen a floppy disk, right? I have a couple up here on the wall up there and stuff, just old sort of ones. That back corner computer still uses them. You guys probably had them in your youth. They probably still were around. I don't know. One day that icon will mean nothing to people. Okay? I just think they will. Anyways, that's the save icon. So let's go ahead and click that. All right? You can usually probably click either one. Actually, the one I recommend is the one that looks like a pile of them. It's called Save Project. Okay, so up pops a simple save window. It basically asks you for the name. Luckily, we already put the name in, so it gives you a second shot. If the first time when it said Windows Application 1, you just went, go ahead, now you have a chance to rename it as you're saving it. But we got a good name. We next need to save it in a location. This is important to you because I don't care where you save it. I could care less where you save your work. But you're going to be the one complaining if you can't find your work later. And I'll be like, well, my first question is, well, where'd you save it? And you'll be like, I don't know. So that is the super important thing, is where are you saving it? And you want to click the Browse button and pick a spot. I'm going to save mine right now on my desktop. I don't recommend that. You could. But I want to show you what happens when I save it. So I'm going to browse to my desktop and save it there. Okay? Notice there's an automatic checkbox checked off that says it's going to create a directory. That's a folder for the solution. So I hit save. Okay? Now, sitting on my desktop now is a folder called Hello World. This is what I'm talking about. This is different than, say, Microsoft Word, where it would just have one Word file. If I take a look at that folder, inside that folder is two things. One, another folder, and two, a file that ends in, you guys might not see what it ends in, but it ends in SLN. It says helloworld.sln. SLN stands for solution. This is a file type that's now associated with Visual C#. So if you ever double click that, it will open C# and open the whole project. Okay? I don't recommend that. I recommend when you want to open an old project, go to C# and go to Open Project, but that's another way you could do it. But notice as well, inside that other folder is way more files and way more folders. And inside there is more folders and more files. And it's just a big mess of stuff you don't want to mess with. Question?
How would you recommend starting your project from Visual Studio 6 instead of a default?
Great question. So let's say we're done for the day. You guys don't need to do this, but let's say we're done for the day. Close up C#, log off, go home, come in the next day. I'm like, okay, time for computer science. I would recommend just starting C#, right? Just start it up. Because sitting now, and you guys could probably do this if you want, shut C# down, start it back up, pretend you went home, and now you probably will see in the start page a little list of recent projects, including the one you were just working on, okay? Now let's say you're 3 months down the line and it's not showing up because your list of recent projects got too big. You're just goofing around, you did tons of projects and it's not showing up anymore. What I would then recommend is I would then go to Open Project and find that place you saved it. So I'd go to my desktop, and there it would show me this folder called Hello World. I'd go into the folder and open the solution file. To me, that's a little more confusing. So I find in the times I've taught C#, most students don't ever have to do that. That list of recent stuff covers the whole course. And I mean students who do tons of stuff. It's always there. So that's going to be the easiest thing for you. Okay? All right. So good. We've got our project. It's saved. We can always get it back. Our work is there. We've got stuff we can bring in there. Now your next question probably will be, I like the two buttons, but I don't want them to say button 1 and button 2. I might want them to say like, OK, cancel, or something like that. I want to change something about them. Okay? Well, let's see what you guys remembered from yesterday. Yesterday, I said the different parts of your program are considered what? It was a word that started with an O, and I used the stool as an example. An object, right. I said that they are objects in your program. Objects that relate to the idea of object-oriented programming. But then I said something else. Objects consists of two things. I'll give you the second one. The second one was methods or functions or things you can do with that object. Okay? We're going to ignore that. What was the other thing I said objects had? Properties. That's right. Properties was the second important thing. Super important. Why? Because the next thing we're going to look at is a little tool window that's now going to be found over on this side, and guess what it's called? The Properties window. So you're going to fly it out, and I'm going to recommend you lock it in place. Now, you can resize these things too. You can kind of organize them, you can drag them out and stuff like that. Now, how is the Properties window important? Well, the Properties window is super important because you can use it to change properties of each object. Now, before you do that, in my thing that's up here right now, how many objects are here? How many people think 2? How many people think 1? Well, then, if you don't think 2 or 1, or you don't want to answer, what is the answer? 3 is correct. Why is it 3? Well, there's a button. That's 1. There's another button. That's 2. What's the third one? The form itself is an object, right? Or the window. Yeah, let's call it form. That's what we want to call it now. Train your brain a little bit to call it a form. Each one of these has a set of properties with it. Some of them are different, right? Things that are properties for a form might not be the same as properties for a button. Some of them are the same. So let's click on one of our buttons. Just single click. Don't double click or you're going to get into this whole code thing. We're a little too early for that. And now you'll see over here in the Properties window, it says, oh, okay, you're looking for the properties for button 1. Which, by the way, you can also use as a way to select your properties. If you go over here and click on the little drop-down arrow, you can also find all 3 properties there, right? Button 1, button 2, form 1. Yes? It's gone? Okay, so if it disappears, once again, go here to Window, View, Other Windows, and you should be able to find Property Window. And then if you want to lock it, click the pin. Okay, so we want to change something about the button. Let's go down to the property. These are in alphabetical order if you have that thing that says A to Z checked off, which I think it is. Down to the property called Text. T for text. And right now you see it says button 1. Let's change that. Let's make it a OK button. And when you type it in and then click Enter, notice it changes over here. Now I'll change this one to the text to say cancel. Okay? So notice, I use the Properties window to change properties of the thing I'm working on. This is a little different than programs like, say, PowerPoint or something like that. In PowerPoint, you kind of do it right on the thing. Whereas here it's using this little Properties window. That's because we can be more specific, okay? Like in PowerPoint, you can do things like change the text, change the background color, maybe change the color of a line around it, change the font. Well, we can do all that too, but we can do even more specific details in the Properties window. Some of those details are programming type details. So I'm not going to go over every single thing in this list. It's not relevant to me, okay? Some of them you're never going to need. Some of them you'll need and you'll explore, and that's part of the first assignment is exploring this stuff. Question? that was going to be my next example. Let's change the font, but not on a button. Let's leave the button standard. Let's just put some text on our thing, and we'll change the color and the font and stuff like that of text. For that, you're going to find the object in the toolbox called a label. That's the simple name for it. We're going to take that label and we're going to draw something on there. And for good luck, inside the label, let's put the words, hello world. Okay? So we've got a little label here. It says hello world. Got 2 buttons. If we want, we could run this right now. Take a look at what it looks like. There it is. Looks right. Now, what we don't have is anything that does anything. Like we've got buttons, and you can kind of do this, but they don't do anything. That's okay. We'll get to that. That's obviously the next thing we're going to look at. But now, the question was, how do I change the font? Well, I select the object I want, which is the label. I then find the property I want to change. There's one called font. And alongside here, what you see when you go to font is a button with 3 dots on it. There's actually a name for those 3 dots. You'd have to be kind of a little bit on the techie side. But does anyone know what that's called, 3 dots? Starts with an E. No. The 3 dots like that is actually called an ellipse. That's a useless piece of knowledge. But you want to click on that button, and what you'll see, what that generally means, whenever you see an ellipse, it generally means another little dialogue is about to pop up, which is exactly what's going to happen, right? So I'm going to click that. Up pops a little dialogue that goes, oh, I want to use Mistral Bold size 26, and then click OK. OK, that's what I wanted, right? I wanted that. Or I can go back to it and go, well, yeah, actually I wanted Monotype Corsivia size 72 in italics, and click OK. Right? So that gives you that creative thing there. But you got to work with this properties window. Okay, what's the next thing I want to say change about this label? How about the color of the text? So you might think, okay, well, I'm just going to look up color. I bet you it's color. So I scroll through this list, and I go to the C's, and I don't see color. Time to think a little more specifically. Just like in our first unit, don't think generally, be more specific. There are essentially 2 colors I could change with that thing. One is I could color in the background of this rectangle. And 2, I could color in the color of the letters. What's a way I could describe the difference between those 2 colors? I know one of you knows. Not border, that's a good guess. Well, the one behind the text would be the background color, and in front of that would be foreground color. That's right. So now you'll notice here's background, here's foreground, 4 color. They shortened it. And I can click on that, and here it gives me a little drop down of colors. Okay? But maybe the drop down doesn't give me all the colors I'm looking for. So then I could go here to web or to custom. Ooh, custom. Now, in this program, it only still gives you a limited number of colors. Once we start coding, you will have an unlimited amount of colors. But for now, I could say make it blue. Okay? And I could go to background color if I wanted to, and I could customize that one as well. That's awful. If the graphic arts people saw this, they would throw me out of the building. But you get the idea. You can be creative. And this isn't a graphic arts course, so don't worry. Your horrible color scheme, as evident by some of the way some of you dressed, is not going to be an issue in this course. I wouldn't pick out anyone in particular. All right. Okay? Those are some of the things you can start doing. This opens up a wide array of stuff to do, though. Okay? There are tons of tools in the toolbox. Each tool will come with a set of properties, different properties, tons of stuff to play around with. None of this stuff will actually do anything yet. It's all just making a look for your particular project. Okay? And that's important, though. I need you to get used to this. I need you to be comfortable with this. Here's the way I generally describe the course. In the first couple units, you'll probably be spending 90% of your time doing this stuff, drawing, and about 10% of your time writing code. to get it to do what the simple assignments I'm going to start with. But by the end of this course, those numbers basically reverse themselves. You'll spend 10% of your time doing this and 90% of your time writing code. By the final project, I would probably jump that up to 95, maybe 99% of your time writing code and 1% of your time doing the little design. Okay? But the design is important. It's what the user interacts with. So you want it to look nice, right? So, everything I just talked about as well, everything I just talked about, just to quickly flip through, is also available, whoops, in the presentation that you can read in the notes folder. So if you felt lost about what I just covered, okay, if you're like, what? You can also get at all this stuff, and I'm currently recording this, so this will also be up on YouTube. So all of this is in there. So we went through this, a little bit of this yesterday, but notice here I have a slide that says here's the project window, here's the menu bar, toolbar. It's all outlined for you, so you have a bit of reference if you need it, okay? I go over like the menus, I go over the toolbox, the toolbar, the project, like it's all kind of in there, okay? Then I talk about what I just talked about with you guys, that it consists of a form. Every app consists of at least one of those, and actually for most of the course, it'll just be one. By the end, we'll start playing around with multiple ones, okay? Forms will contain other objects, like the form itself, the label, the button. You got it, like that's all there, okay? When you're building this, this is what's called design time. You do the design process, okay? Here I walk through an example of how to add a label. We've already done that, okay? You can also do it, as it says here, by double-clicking it, and it'll pop it on there, okay? By the way, if you want to remove it, press the delete key, not the backspace key. Some students still think that I'm talking about the same key when I say delete and backspace. I'm not, okay? Please know the difference. The delete key and the backspace key are two different keys. Okay, then the properties, which we can change using the properties window, and I outlined that as well for you guys. So everything we just did is also in the notes, okay? Then I do an example, okay? And that's a true statement. And it changes the properties, right? And then the saving process, also covered in here. And then how to run it, also covered in here, okay? The one that I didn't cover, which you may need, I doubt it, but there might be a time where your program seems to get stuck or frozen, so to speak. You can actually stop your program without clicking the red X by going and hitting stop or hitting Shift F5. You can see this. It's a menu option here. Just know that that exists. Most likely you'll just go, hey, Mr. Woggs, how do I stop this? But that's also in the notes, and that's it. So all thing I have left to do is show you the first assignment now. All right, hang on one sec.